Do. Okay, hey, how you doing there, Earthling? This is your Chapter 2 test. You're taking it on Edge Elastic and listening to it courtesy of your favorite teacher, Mr. Brooks. So here we go. Question number 1, we want to figure out what the next picture in the diagram would be. So take a look at the orientation of the shaded area. A, B, C, or D, which one is the next picture in the figure? Okay, that's question number 1. Question number 2 asks what's the next number in the pattern. So let's zoom in here a little bit. Whoa. Okay, I got it under control now. So what's the next number in the pattern? So I want to look at, I'm going from little to big numbers, okay? And what do you think we're doing? We're either adding or subtracting, right? So you need to figure out what's the pattern to get us from 2 to 4, and from 4 to 8, and from 8 to 16. And then what is the next number after 16 in the pattern? That's question 2. Zoom out here a little bit for question number 3. Okay. Which choice down below here, rectangle, square, or a parallelogram? And I'm going to draw a picture of each one of these. You know, a rectangle has 4 sides, and it has 4 right angles. Square, obviously, 4 right angles, and all the sides are the same. A parallelogram is going to just have 2 sets of parallel lines. So that's what they look like. The question below, which of these is a counterexample? All quadrilaterals are equilateral. So all quadrilaterals, those are 4-sided figures, are equilateral, meaning they have the same number of sides. So which of these would be a counterexample, proving this wrong? Because it is. All quadrilaterals do not have equal sides. Okay? And I guess one thing I will change this is a parallelogram. This could be, actually, let me take that back. I take that back. A parallelogram does not have to have equal sides. Okay? So which of these, you check all that apply. I'll give you a hint. It's 2 of them. So which 2 proves that quadrilaterals are not equilateral, meaning all the sides are the same? These 3 over here, of those 6, so it's not just 2, it could be more. Pick all that apply, where a quadrilateral is not an equilateral, okay? Okay, oh, and I guess I didn't see this. To continue back on the last question, you could have a rhombus, kite, or a trapezoid. I did not see these choices here, and I apologize. A rhombus is a parallelogram, but all the sides are equal. A kite is, well, it's a kite. You got this side's equal to that side, and these 2 sides are equal. And then a trapezoid is going to look like this. Okay? So out of these 3 and... So now, question 4 is a proof. Or I'm sorry, not a proof. If I can get the page to move. It doesn't want to move. Okay, back to number 4. You're going to drag and drop if, then, inverse, converse, contrapositive, and biconditional. So you're going to drag and drop. Now I want you to remember that, if, then, it's just that. Soccer players are athletes. So you're just going to take the statement and just add if and then. Now the inverse means that you're going to flip the if then. From back to front and front to back. I'm sorry, I totally said that wrong. Inverse. The inverse means we're adding the words not. So if you're not this, then you're not that. The converse is we're going to flip the if-then statement. So you're just going to flip it, end for end. The contrapositive, you're going to flip the inverse. So take your inverse with the words not and flip that. And then lastly, your biconditional is, it's going to say like, it's raining today if and only if, okay? So you're going to have the words if and only if in your biconditional, all right? So you're just going to drag and drop. You got 1, 2, 3, 4, 5 choices, and I believe you only have 4 questions down here, unless there's one on the next page. Let's look. Okay. So you're only going to use 4 out of the 5. I'll give you a hint. You're not going to use biconditional. Okay? So you're going to use one of those 4 that I already talked about up above. There is not. Number 5, we want you to rewrite the following as a biconditional. So now you are going to use the words if and only if. And you just want to kind of plug those into the middle. So the statement is, collinear points are points that lie on the same line. So you're going to put in if and only if somewhere in the center and retype that. Number 6, we're going to use law of detachment or syllogism to retype the sentence. So what conclusion can you draw from this statement? If you save $30, then you buy a CD player. You have saved $30. Now this would be detachment. So what conclusion do we come now? The fact is, if you save $30, you can buy a CD player. Well, Bill here has saved $30. So we can conclude that he can do what? Type that in right there. And then B, which was this? Was this law of detachment or syllogism? I may have accidentally just told you that. Question number 7. Same thing, law of detachment or syllogism. So here's part B. So which of these is it? Remember, syllogism deals with, we take out the part that repeats. So what conclusion can we make? If 6x equals 30, then x equals 5. If x equals 5, then 2x equals 10. Is there a repeating part here? If so, that might be this. Rewrite your statement down below. If you have questions, make sure you ask. Okay. Question number 8. Select the words that make the conclusion true. All right, so which of these 3 will make this sentence true? The Empire State Building is in New York City. Sam vacationed in New York City. So Sam, what? Visited the Empire State Building. Is it that Sam must have visited the Empire State Building? Is it Sam may have visited? Or Sam never visited the Empire State Building? So the Empire State Building's in New York. Sam went on vacation to New York. So just think, he went on vacation. Did he have to go see it? Which of these 3 would be best to put in the blank here? Okay, number 9, the conclusions must be on the next page. Let's take a look. I'm going to write these down right here. Is not, and maybe. So those are the 3 choices. Okay. Some tourist sites in New York City are accessible when accompanied by a tour guide. So Sam blank visiting tourist sites in New York City with a tour guide. So Sam is visiting tourist sites with a tour guide. Sam is not, or Sam may be visiting sites with a tour guide. Because some tourist sites are accessible, meaning you only see them with a tour guide. So which one is not, or maybe fills in the blank in number 9? They are, and it's is not, and maybe. So let's go back here. Number 10, okay, you need to basically look at how they're solving this problem. Maybe write in the steps like I would. I'd say, okay, they did this first. So then down here, we're going to drag and drop what operations did we do. You got addition POV, subtraction, multiplication, division, substitution, or distributive. Make sure you don't mix up substitution and subtraction. Okay? There's only 2 of them, lots of choices. But just whatever the step is, put that in the next line. Question 11 is the same thing, just slightly different, a couple more steps. So question number 11, guys, all we got to do is choose one of these to go in down here. And again, actually write out the problem. Work out the problem on your own. Fill in the steps, okay? That'll help you in determining which of these properties goes in the box. Okay, number 12, the exact same thing. Just doing another problem. Okay, they did all the work down here for you. You just need to find the property that goes into the box. On 13, we're telling you that ABD and CBE are straight angles. So there's a straight angle and there's a straight angle, meaning they're straight lines. Which 2 theorems can prove that ABC, okay, and I'm going to remark these, that ABC, this segment here, and DBE, right here, are congruent. Okay? Now you got congruent supplements, right angle congruence. So you want to make sure you flip back and take a look at these angles. They're made from intersecting lines. They're back to back from each other, and they are equal. Okay? So you got congruent supplements, meaning they add up to 180. Is it right angle congruence, meaning they're right angles? We're on the next page. We got a few more. Congruent complements, linear pair, or vertical angles. Okay? Or does it mean congruent complements, meaning they add up to 90? Linear pair postulates, meaning together they make a 180? Or are they vertical angles? That's number 13. Question 14, we're going to complete the proof. It looks like, yep, the start of it's here. Okay. So here's your given. ABC is a right angle, and then BD is a bisector. So it means he's splitting these 2 guys into smaller ones right here. All right, so there's your big right angle. Here's 2 smaller ones. And they're also telling you, and it's good to write this in, maybe draw the picture yourself, DBC is 45 degrees. Okay, when they give you information or as you learn it, it's good to write it in. So on the next page, all right, here's all the steps. Here's all the statements. And here's the potential reasons that go down here. Now remember, the first one's always given, maybe even the first 2. We got 2 potential givens. So double check these on the last page and see if they're given or what is given. Okay? And then just look at what changes and which one of these, definition of right angle, angle bisector, or simplify. Okay? There's 1 for each. There's 5 blanks. There are 5 drag and drops. And that is the end of your Chapter 2 test. So if you have questions along the way, make sure you ask me. Have a great rest of your day. Bye.